Hello everyone, in this video we are going to solve problem 116 of chapter 2. Determine the angle theta between the y-axis of the pole and the wire AB. One of the application of dot product was finding the angle between two vectors. So if we want to find the angle theta, we need two vectors. So our vectors could be the position vectors because we have the dimensions here. So my first task would be to find a position vector RAB. And the position vector RA, if I call the origin O, RA, O. So this vector, and also this vector, RAB and RAO. So RAB would be 2i if you're going towards positive x, negative j, and negative 2k. So by now you should be able to write a position vector. When we are moving from A to B, we are going towards positive x, so that's 2 feet. And then negative j, here the y component for a point A is 3 feet, and a point B is 2. So we are going from 3 to 2, so that would be negative j. Also, we are going in the opposite direction of v. From A to B, I'm going down 2 feet. So that's y negative 2. So I'm going to write the unit for the whole position vector, which is feet. Or AO is simpler, just moving along y-axis. And then from A to O, you're moving in the opposite direction of positive y. So that would be negative 3j. And the unit is feet. So now I can find a cosine of angle between the two. It would be RAB dot RAO, the magnitude of the two, RAB multiplied just scalar multiplication, RAO. These are the magnitude in the denominator. So cosine theta dot product of RAB, RAO. So I have 2 here. There is no I component. So that would be 2 times 0 plus, here the j component is negative 1, and then here the j component is negative 3. So negative 1, negative 3 plus the k component. Here is negative 2. Here I have no k component, so 0. So negative 2 times 0. Negative 2 times 0. So these two components are going to be 0. Anything multiplied by 0 would be 0. Negative 1, negative 3 would be 3. Then in the denominator, I have the magnitude of AB and AO. So I have 2, 1, 2. That would be 4, 1, 4. That would be 9. So I have a square root of 9 here. And here also a square root of 9. So numerator would be 3. And the square root of 9 would be 3. So that would be 3 times 3. So 1/3. And theta would be cosine inverse of 1/3, which gives me 70.52 degrees. So I found the angle between the two vectors, the two lines. To find the angles, I use the dot product definition, and I found the position vectors. And the direction of the position vector is important when you want to find the angle between the two vectors.